Creating a new thread for every task is wasteful. Python's ThreadPoolExecutor gives you a smarter way to handle concurrent work. ThreadPoolExecutor manages a pool of worker threads that execute tasks concurrently. Instead of spawning a new thread each time, it maintains a fixed set of threads ready to process work. When you submit a task, the executor assigns it to an available thread from the pool. If all threads are busy, the task waits in a queue until a thread becomes free. It implements the executor interface, letting you submit callable or runnable tasks using the submit method. Each submission returns a future object, which acts as a placeholder for the result. You can use the future to check if the task is done, retrieve the result when it's ready, or even cancel the task if needed. The real benefit is thread reuse. Creating and destroying threads is overhead. CPU time, memory allocation, context switching. By reusing threads across multiple tasks, ThreadPoolExecutor eliminates that waste and significantly improves performance, especially when handling many short-lived tasks. You can configure the pool with parameters like max workers to set the pool size, thread name prefix for debugging, and initializer functions to set up each thread. This flexibility lets you tune the executor for your specific workload. ThreadPoolExecutor efficiently manages concurrent tasks using a reusable pool of worker threads. Practice using it in your next Python project and see the performance difference. Want to nail questions like this in your next interview? Interview Mentor gives you hands-on practice with real questions. Every answer gets a grade with specific, personalized feedback. Track your progress across topics and difficulty levels.